Hey, welcome guys. Welcome to episode 1 of Audio Operations in Python series. Before we write any Python code, we need to understand what audio data really is. If you don't understand sampling rate, bit depth, PCM, mono versus stereo, your audio processing will be guesswork. So let's start with the fundamentals. Let's understand what is digital audio. When a microphone records sound, it converts air vibrations into electrical signals. A computer cannot store continuous waves, so it converts them into numbers. Like I have shown here, digital audio transforms continuous sound waves into discrete numeric samples, and computer can save that particular sample. And digital audio is nothing more than a long sequence of these stored samples in a file. And this is how our digital audio creates. This digital audio uh, its quality depends on number of samples. The more number of samples, there is a better quality of that particular audio sample. Let's understand the sampling rates. Sampling rate means how many samples per second are captured. There are multiple uh, common sampling rates which starts from 8 kilohertz. This particular sampling rates usually used in basic voice communication or minimal quality of for speech, like a telephone quality basically. Then second thing is 44.1 kilohertz. It is a CD quality. Most of the standard music consumption is used by this particular quality. This is an excellent quality for most applications. Then third is 48 kilohertz. Usually we use this for YouTube and video, and this is a professionally used video standard and widely used in digital media. And here one thing we have to keep in mind that higher the sampling rate, better the fidelity and better the quality. More samples per second captures more details and higher frequencies. So higher sampling rate is equal to more accurate representation of the original audio. So let's understand what is a bit depth and audio precision. 16-bit is a CD standard and 24-bit is a studio quality. 62-bit is a standard for consumer audio which provides good dynamics range for most music. Like it contains 65,536 possible values for that particular sample, and it is in 96 dB dynamic range, and it's sufficient for most of the applications. Let's understand what is a 24-bit audio. It's mostly studio quality and it will be used in mostly professional recording standard. Maximum precision for audio production. It can save up to 16.7 million possible values. It is 144 dB dynamic range and it's essential for mixing and mastering. Usually in movies and all, we use this particular 24-bit format. Then let's move towards what is PCM. PCM, it stands for pulse code modulation. It is a fundamental digital audio format that represents sound as a sequence of numeric sound or samples without compression. There is no compression here in PCM. Okay, it is the rawest and most accurate digital audio format. Most of the WAV files or WAV files use PCM. PCM means no compression and no loss of quality. It's the best for editing. Then let's compare different audio format. The best quality you will get in WAV format. The quality is excellent. Then FLC also excellent. In Wave there is no compression, so comparatively the file size will be moderately higher, and it basically used in professional editing and processing. MP3 is good quality, uh, compression is lossy type, then it's mostly used for music streaming and web distribution. Then FLAC is again excellent quality, then lossless compression, audio archiving and high fidelity storage. And one more, not last but not least, is AAC. Very good quality, compression is lossy, and use case mostly in YouTube. iPhone uses this format. Then modern streaming platforms use this particular format for a better quality. So let's understand mono versus stereo audio. Mono audio will be having only single channel. Single channel audio is suitable for speech, then podcast and machine learning applications. Second thing is dual channel, where two channels are present, where you will get immersive spatial audio experience for music and entertainment. Let's see stereo use cases. For stereo, there are multiple use cases like music production, film audio, immersive media experiences. For mono use applications like speech recognition, voice recordings, and ML training datasets. So let's see. So this was the first video where we are learning the fundamentals or basic of the audio processing Python. What we will be covering? So we will be covering how to read audio files using Librosa or SkyPy to load audio files in the form of NumPy arrays. Then we'll check the array shapes. We will examine the dimensions, samples like mono or stereo audio samples. Then we'll plot the waveforms, like visualize the audio using matplotlib for analysis and debugging. And then I will show you some practical Python code snippet for common audio operations and analysis. So if you are new to this channel, make sure to hit that like button, subscribe the channel and press the bell icon so you won't miss any further videos. So that's it for this particular video. We'll meet in the next video. Thank you.